Okay, now for example number 1 from 3.1, we're going to solve or find the solution for a system. And so systems are nothing more than 2 lines. So I might have one line and another line. So I've got this line and this line, and those are linear equations, and this would be what we call the solution. Okay? Now this is a very common model in economics or business. For example, the blue line could represent the cost of manufacturing something, right? If I buy the materials that I need to make something in bulk, I get a little bit of a price discount. If I run some sort of assembly line or I invest in machinery that could over time reduce my cost, this blue line could represent the cost to manufacture something, right? Based on the units that I sell, right? So this could be like the units, and this could be the dollar amount. And so this red line could represent like the cost, right? Or no, the red line could represent like the profits. The blue line could represent the cost, right? So it's going to cost me a lot of money at the beginning, right? Because I got to invest in manufacturing machinery, training for the staff, importing a bunch of materials, all this stuff. And so a lot of times in business we'll do this model. It's also very similar to a supply and demand model. But we want to find a break-even point and when we're going to start making some money. Okay? And so that point would occur here. And so the math that I'm going to teach you today will help you find that point. It also helps me to figure out what my initial investment would need to be. Right? I'm going to have to buy all this stuff. How much would all that cost me? Well, that would cost me the Y amount. And so I have to guarantee that I'll sell at least that much stuff to break even. Does that make sense? All right, so how do I solve that? Well, example number 1 gives us 2 equations. These are both linear. Negative 3x plus 2y equals 8, and x plus 2y equals negative 8. And there's lots of ways that we could solve this. For example number 1, we're just going to do it graphically. Now, graphically, your calculator can't graph things this way. But Mr. Adams does have a website, and that website will let us graph it written in the standard form. And that's the main reason I put it on there. In a little while, at the end of this example, what I'm going to do is I'm going to show you how to convert that to a graphing calculator. Basically, we need to take the standard form and solve for the slope-intercept form. But for time's sake, just because I'm trying to teach you the concept, what I'm going to do is I'm going to put my little graphing calculator over here. So I think what I might do is, Okay, so now I'm just going to type that in there. So I've got negative 3x, where's my plus sign? Plus 2y, oops, I want y, is equal to 8. Okay, so that's one. And then the next one I'm going to plug in, the next graph is going to be x plus 2y is equal to negative 8. I just want to make sure, check my graphs real quick. Does that look right, guys?
Yep.
All right, cool. So now what I'm going to do is I'm going to slide this up so I can look at it. And let's kind of zoom in on that. All right, so where does it look like it crosses at?
Right there.
Negative 4, negative 2. All right, so it looks like it crosses at negative 4, negative 2. So the solution, we think the solution is negative 4 comma negative 2. In other words, x equals negative 4 and y equals negative 2. Now, I want to verify this. And so one way to do that is to plug it into the original equations and see what I get. So, in other words, when I plug in, if I take my original equation, 3x plus 2y, and I plug these values in for x and y. In other words, I plug in negative 4 for x and negative 2 for y. Negative 4 times negative 3 is a positive 12. Negative 2 plus negative 4 is negative, or I said the answer. 2 times negative 2 is negative 4. When I add those up, do they equal positive 8? Yep, sure do. Now let's try the same thing with this equation. I'm going to write over here because I'm running out of room. I'm going to take x plus 2 times y, and that should equal negative 8. Well, what's x? Negative 4. What's y? Negative 2. So I get negative 4 plus negative 4 equals negative 8. Does that work?
Yeah.
Sure does. Okay. Any questions on that? So that's one way to solve that. Now another way to solve that would be to plug this into our graphing calculator. Well, that's not that easy. So let me copy this, and I'll start a fresh screen. All right. And let's paste that. Okay, cool. So now another way to do that is to take these equations, like 3x plus 2y equals 8, and I want to make it look like y equals mx plus b. Remember, just a quick review, that m represents the slope and b represents the y-intercept. Whoops. Okay? But remember, in our calculator, everything's like y equals, right? Yes, question?
I want to do it.
You want to do it? All right, come up to the board. While you write it down, I'll explain it. So, we have a volunteer who's going to write this down. What would you do first? All right, so he's going to add 3 to both sides, add 3x to both sides. What he's really doing is moving stuff away from the y, and the easiest thing to move is the positive 3x. Also notice that he puts the 3x in the front and the constant 8 in the back, so it looks like mx plus b. Do we have y by itself? No. So now he's going to divide everything by 2. Okay? And so the 2's on the left-hand side cancel, and you get y equals 3 halves times x plus 8 divided by 2, which is 4. Okay. Thank you very much. Good job. So there we go. That's our first one, right? So we're going to graph that in our fancy graphing calculator in a second. Do I have another volunteer that wants to do the next one? All right. Don't worry, there's plenty of example problems. Go ahead. All right, so the next one we're going to solve is x plus 2y equals negative 8. So just write the equation down first and see what we get. X plus 2y equals a negative 8. And remember our goal, we're just solving for y. That's all we have to do. So what would you move first? Very good. He's going to subtract x from both sides. And so the x's on the left-hand side cancel, leaving us with 2y. He's remembering to put the x in the front, so it looks like mx plus b, right? And then lastly, he's going to divide everything by 2. Okay? So then the 2's cancel, and he gets y equals negative 1/2 times x, and then negative 8 divided by 2 is negative 4. Okay, cool. So, wow, tough room. All right. So now these are our 2 equations. Now remember, Mr. Adams graphed it and it looked like this. But when I go to use my graphing calculator, my fancy schmancy graphing calculator, when I go to plug stuff in, I only have this y equals stuff. So what I'm going to do is I'm going to come back here, put my fancy graphing calculator off to the side, and I'm going to say for my first y equals, oh, I got to change this. I was doing some inequalities the other day. You know how it is. Just doing little inequalities one day. Oh, should I match the colors? Let's match the colors. So I'm going to make this blue, red, right? That's the first one. All right, and okay. All right, so my first one, which is in red, I'm just going to put in parentheses 3 divided by 2 times a variable x plus, I think that's a 4, although it kind of looks like a y. And then for the next one, let's change that to blue, right? So I'm going to hit enter, blue. Now we'll do navy, close enough. And then, I don't know, there's like 16 or 32 colors, I don't know, I don't want to do them all. So now next one we're going to do in parentheses, -1 divided by 2, close parentheses, times x minus 4. I'm going to graph them. What? Where does it look like it intersects? -4, -2. What?
No one asked.
Boom. -4. Boom. Now, how can I let my calculator verify the intersection?
Trace.
Yeah, so I'm going to, well, second trace, right? So if I hit second trace, pulls up the calculate menu, intersect is 5, get as close as I can, first curve, second curve, guess, obey him with the bacon sizzle, -4, -2.